Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shazmi bin sepeeh from University Tuhan Malaysia. Today I'm going to present the project entitled of real-time monitoring for mechanical boiler chamber using IoT application. This project is carried out by 3 people under supervision of Dr. Syamsul Azlan Zulkifli, me, and one of my colleagues, Muhammad Amirul Ahmad Fauzi. This project is involved with IoT application, is where Internet of Things can collect real-time data and transfer it to the Internet cloud to be managed by the user at any place. The advancement of phone apps, the phone and all smartphone connection with IoT reduces the gap between physical and digital, especially in this industrial. The high level IoT where the SCADA system collect more measurement from the peripheral and convert the information to the computer program format for the next step process. In this project, the IoT application has been applied to the mechanical boiler chamber that required the temperature, vibration, and motion for complex operation to avoid a broken section. This project, which is used the ESP module, which is a microcontroller, which is a smaller size that's suitable for sensors that needed to reduce the cost of the system, and at the same time, the ESP module has its built Wi-Fi module. As for the boiler concept, protecting the boiler from the overheat is by applying sensor that can notify the condition as quickly as possible. It broken the overheat and prevent intruders such as rat that affect wireless performance. Here is the IoT interface between the microcontroller and the Blink apps on the smartphones. The temperature sensor is being applied to the temperature sensor, vibration sensor, motion sensor is being applied to the ESP module with the LED as an indicator. So the data is and the signal is sent to the Blink X through the Wi-Fi, where the Blink X will show the temperature reading, vibration reading, motion reading, and also inclusive of cut-off button whenever the boiler chamber face the failure. So the cut-off button will be used to shut down the operation. Here is the flowchart of this project, which is the first one is the flowchart of the process of the project. Each of the sensors connect to the MCU, and then we need uploading the code from the Arduino, and it's the Arduino serial monitor display the value, and the output value from the sensor is displayed. And if not, identify the error and troubleshoot the code. And the second is the flowchart of the sensor integration for the system, where the sensor detects the temperature changes, motion, and vibration, and then the signal from the sensor discrete from the node MCU, and then the value is presented. If not, it's going back to the previous step. And if yes, the Blink software display the data. And the third is the flow of the Blink process, where we create the widget on the Blink apps widget box by using the widget box and assign the pin value in the Blink. Verify the code with Wi-Fi ID and password, and then we upload and run the code from the Arduino software into the MCU. And if the result display, the result monitor using the smartphone. If not, we troubleshoot the error by editing the codes. And here is the IoT hardware setup that consists of temperature sensor, node MCU, LED indicator, vibration sensor, and also motion sensor. And on the right hand side, as you can see, the boiler chamber and display on the Blink X smartphone. And here is the C code that we create to monitor the temperature, vibration, and also motion. So on the right, as you can see, the serial monitor display that display on the Arduino software to see the signal that have been read. And on the result, as you can see here, the sensor output notification on smartphone that with a vibration, motion, temperature at 40 degrees Celsius, and also temperature at 60 degrees Celsius. And so in this case, we investigate with the two testing, which was the heat from the lighter and also the heat from the boiling water. The cutoff limit is indicate so that the Blink S will show the notification on the Blink on the smartphone. when the cut-off limit is reached for the temperature sensor. It happens also on the vibration sensor, where when the sensor is detect above the 74 units, so it indicates that the boiler is unstable. So the notification is pop up on the smartphone with the warning notification. And also it happens also on the motion, where the unstable mechanical chamber produces the motion, and the motion is detected, and the notification of the motion is also shown on the smartphone. And whenever the microcontroller is press the failure, so the cut-off button is used to shut down the operation. And here is the video of the testing of the IoT application on the mechanical boiler chamber. So concept of motion sensor and also the temperature sensor. This about to indicate the shutdown of the mechanical boiler chamber. As you can see, the temperature on the graph on the smartphone is increasing, so the temperature of the temperature high pop up where the temperature is reach the limits. So this is the motion sensor. It will detect the motion in the mechanical boiler chamber application. So as you can see, the motion is detected on the Blink apps. It's the vibration sensor. So when the vibration sensor detect above 74 units that is set up, so the unstable notification is pop up on the smartphone. So this is the cut-off button by using the relay. So it will shut down the operation of the boiler chamber. So here for the video testing. Next, the last is the conclusion. In conclusion, designing the dashboard of the Blink in the smartphone gives a new way to integrate the hardware and IoT network. Therefore, this project has been able to apply IoT system configuration that can be used for remote monitoring system, especially for the boiler system where required 24 hours monitoring. All the sensors are being integrated into each other, where the temperature sensor is essential and needs to be monitored in continuous mode with display the actual data display and give the initial warning of the boiler. Besides that, the vibration of the chamber must be frequently observed to estimate any surface cracking that appear. As for the motion sensor is to see if any displacement of the boiler that require high maintenance costs in the future. The development of heat and vibration monitoring system for IoT application to obtain real data result has been successfully connected and created a real-time monitoring system. With that, I end the presentation with thank you.